In this video, we are going to look at some theorems and work through three problems involving arcs of a circle formed by two intersecting lines where those lines intersect at a point outside of the circle. In the diagram we're looking at, the two lines meet at point E at an angle of 50 degrees. And these two lines subtend two different arcs of the circle. On the far side from E, we have the larger arc CD, and the closer and smaller arc is AB, and we can see the measure of each of those, and notice that the measure of CD happens to be exactly 100 degrees larger than AB. Now I'm going to move this circle around, and as I do that, the numbers are going to change. If I move the circle closer to point E, both of the two arcs get smaller. As I move further away, both of the two arcs get larger. But we can see one thing is remaining the same. No matter where I stop, no matter where I put this circle, the measure of arc CD is exactly 100 degrees greater than the measure of arc AB. And that is a theorem. The theorem relates these three quantities: the measure of the larger arc, the measure of the smaller arc, and the third quantity is the measure of the angle itself between these two lines. And the 100 degrees here is exactly twice that angle measure. And that's always true. So we're going to look at this theorem. We're going to use it to solve some problems. But first, let's look at some other variations of this idea. If I move the circle to the other side so that the point of intersection is inside the circle, we get a similar situation. The two intersecting lines still subtend two different arcs. In this case, A prime, B prime, and C prime, D prime. I no longer want to use the words larger or smaller arc because depending on where I put the circle, one arc might be larger, the other smaller. As one gets bigger, the other gets smaller, but either one could be the larger or the smaller. And again, something is remaining constant. And in this case, it's the sum of the two arcs. So as I move this around, what arc C prime, D prime loses, A prime, B prime gains as I move in that direction, and vice versa. So if the point of intersection is inside the circle, we add the two arcs, and we get twice the angle of intersection. And if we're outside the circle, if the intersection is exterior to the circle, then we take the difference between the larger arc minus the smaller arc, and that gives us twice the angle measure of intersection. Now, one more variation. If I move my circle so that A and B coincide on point E, or as A and B get closer to that point of intersection, the measure of arc AB gets closer to 0. And by the theorem I just mentioned, that must mean that the measure of arc CD must be getting closer and closer to 100 degrees. And we can see that it is. And so the other variation of this idea, an important theorem that comes up a lot, is if we have an inscribed angle, meaning if the vertex of the angle is on the circle itself, then the measure of that angle is half the measure of the arc it subtends. The arc will be twice the measure of the inscribed angle. So if the point of intersection is inside, we add, outside we subtract. And really, if it's on the circle itself, it doesn't matter if we add or subtract because the measure of that angle will be 0 if the vertex of that angle, the point of intersection is on the circle itself. Okay, so a few variations there, but we're going to focus on this scenario where the point of intersection is outside the circle, and we're going to look at some theorems and then solve some problems. So the theorem from the book, from the You Certify online text, this is in section 5.2, and it's theorem number 14 from that section. It says, if two secants intersect at a point outside the circle, then the measure of an angle formed at the point of intersection is 1/2 the difference of the measures of the two intersected arcs. So this is stating the fact that we just saw, and here it is again in the picture. Angle AEB here is 1/2 the measure of the larger arc CD minus the measure of the smaller arc AB. That's what this says. Now this is really more than one theorem. This is multiple theorems in one, because this is true even if we're dealing with tangents. So this same fact is true for both secants and tangents. And by that I mean, if we go back to our picture here, if I move my circle so that C and B coincide, this fact remains true. Even if C and B are very close to each other, the measure of the larger arc CD minus the measure of the smaller arc AB is going to be twice the measure of the angle of intersection. In this case, it's going to be 100 degrees, no matter where I put these, including if I put C and B right on top of one another so that they coincide. In that case, this will be a tangent line at that point, but the same fact remains true. So whether it's a secant or a tangent, this is a true fact. So if we include that, we can look at other pictures. If we move this so that one line is tangent at point B, this is really the same fact. The measure of angle AEB in the second picture is the measure of the larger arc, in this case BD, minus the measure of the smaller arc AB. And if we have two tangents, same thing. The measure of the angle AEB is the measure of the larger arc minus the measure of the smaller arc. And the notation here, it should be made clear that these are all counterclockwise. So for this last one, the measure of AEB is 1/2. AB is the larger minus BA, the smaller. So it looks like a bunch of theorems, but it's really one idea. And we can use this idea to solve some problems. So let's look at some examples. And these are some problems I took from a web page called mathwarehouse.com, and the address is on the screen. And this page has some ads, but it does have some good information, some good problems. So there's some good practice problems there. And I just chose 3 of them. And first of all, I want to put the right notation. This should be in degrees. And what they're asking in this problem is, what is x? Find x. We want to find x. And so we want to look at the problem, look at the information they gave us. They told us the measure of arc AC is 178 degrees. And the measure of CH is 102. So this is really set up perfectly for the theorem we just looked at. If I want to find x, we can use the fact. What we're going to do is look at the difference between these two measures. If I do 178 and subtract the 102, we get 76. That's not x. We want to look at the theorem. The theorem says the measure of x is 1/2 the measure of the larger arc minus the measure of the smaller arc. So 76 is not x. 1/2 of that is x. So that would be 38 degrees. So that's a direct application of the theorems we just looked at. In this case, it looks like C is a tangent point. One line is a tangent, the other is a secant, and it really doesn't matter. It's the same idea regardless. The second problem has the exact same picture, same configuration, different information. So let's read this again. Let's label the picture. AC is given to us again. That's 158 degrees. That's the measure of the arc that goes from A to C. And in here they give us that x is 68 degrees. And in this case, the unknown is the measure of CH. So this theorem relates these 3 quantities, and in any problem they can give us 2 and we can find the third. And what we're going to use is that same relationship. The measure of x is 1/2 the measure of the big arc, AC, minus the measure of the smaller arc, CH. And we can just plug in what we know. We know that x is 68. We know that AC is 158. The measure of CH, we don't know what that is, but that's the only thing we do not know, so we can do a little bit of algebra here. First, I'll multiply each side by 2. 68 times 2 is 136, and that's going to equal 158 minus the measure of CH, which is the thing we want. Moving this around, if I add the measure of CH to each side, we see that the measure of CH is 158, and I'll move that 136 also. I'll subtract that. So the measure of CH is the difference between 158 and 136. So it looks like this is 22 degrees. And that's our answer. And we can take a moment to think about that answer and see if it makes sense. And the fact that what should work out is if we take 158 minus the 22 degrees, we get 136. That gives us twice the angle of intersection between the two lines. So that looks good. One more variation. And here I blacked out some information. And the reason is they gave us more than they needed to. In this situation, what's different here is we have two tangent lines. And what we're given is the measure of CAH is 205 degrees. When we have two tangent lines, we only need one piece of information. So right now we have two unknowns. We don't know what the measure of CH is, that arc, and we don't know what the measure of X is, that angle. We don't know those two things. So if we're missing two pieces of information, we need two equations. We need two. So one equation is, I'll write it down, same thing as before. The measure of X is 1/2 the measure of the big arc minus the measure of the smaller arc, the measure of CH. So it looks like we have one equation and two unknowns. So the thing to always remember in a circle is when you look at the picture, the total measure of the arc around the entire circle is 360. And so if you have two tangents, if you know one of the two arcs, you know the other. So that's the other fact that we have here, is that we know that if we take 360 and subtract the 205, that comes out to be 155. That's the missing arc. Measure of CH is 155 degrees, and we have enough information to figure that out. Now we can figure out what X is. It's 1/2 205 minus 155, which is 50 degrees. If I take the difference of those two arcs, I get 50 degrees. That's not X, that's twice X. The measure of angle X is 25 degrees.